first start video. I'm going to make some start video now because I'm also learning some start, and I'm going to make some topic that I'm learning. So first our topic will be on quantiles. So let's start. So quantiles is basically called to the collective group, commonly collective group of quartiles, deciles and percentiles. So let's look at each one of them. Quartiles. Quartiles divides our dataset into four groups. Quantiles uses 3 points Q1, Q2 and Q3 to divide our dataset into 4 groups. Similarly, deciles. Deciles divides our dataset into 10 groups, and it uses 9 points to divide our dataset into 10 groups. Again, similarly, percentiles divides our dataset into 100 groups. So we can see, let us consider this in our left window, this as our dataset, data points, and this is our middle. So Q2 for quartiles, Q2 is going to be our middle point, and it is basically dividing it into two groups. Again, sorry, sorry. Okay, again we can do like this. Sorry. Now, now we can see that uh, uh, our data set is divided into four groups: 1, 2, 3, 4. So this will be our Q1, Q2, Q3. Okay. Likewise, if we divide our data set into 10 groups, we will have 9 arrows which are going to divide our data set into 10 groups. Similarly, for percentiles, we are going to have 99 points, 99 arrows like this, which will going to divide which is going to divide our data set into 100 groups. So I have picked up iris dataset in order to show some calculation around here. So let's get started. So first of all, I'm going to separate only petal length of our dataset. So to show our percentile and quartiles calculation. So iris, I'm going to select specific species. I think we have 3 species. I'm going to only select Certosa because we are seeing Certosa here. Certosa. I'm going to select all the data points related which has a species Certosa. So you can see we are getting all the Certosas, and I'm only going to take petal length. So we are getting only petal lengths here. So using this series, we are going to calculate all of its percentiles. Not all of it. We are going to see some of the examples. So let's see how we calculate using NumPy. So NumPy has a built-in. First of all look how we calculate manually. Then we are going to look how we can use built-in functionalities to calculate. So basically, let's calculate our quartiles. Quartiles, Quarti, quartiles, and this is going Q1, Q2, Q3. First, let's calculate Q2 because it is the middle one. We can easily calculate it. Iris, set as a petal length. First, we have to remember one thing. The requirement for calculating all of these is that data sets should be in order, grouping order. Okay, so let's do that. First of all, let's make our data sorted and iris sorted. We are going to use sort values from pandas, and let's see iris sorted. Let's only say it. Yes, we have now sorted, but our index is messed up, so we are going to fix that index as well. uh, reset reset uh, reset index, and we are going to drop previous index. So it is great. Our name is too long, so I'm going to do in place only for now. In place is equals to true, so that we don't have to type again and again. Iris sorted only. So our index are also in place, and our all data points are sorted now. So let's calculate first our middle point, that is our q2. Q2 is just median. Let's first look our shape. Shape is our 50. So then our middle value is going to be 50 divided by 2, 25. So our q2 is going to be on 25 position. So let's mark it down here. q2 is equals to 0.5 again. Now we are going to calculate q1. So what q1, we can calculate q1 in two ways. We can let's say q1 is this here, in this part only. We can ignore this part for calculating q1. So we can calculate q1 in two ways. One is by not including median, this point, and another is by including this point. So it does not matter whether to include or not, because at the end of the day it will converge to the same number. So let's look at our data set. Okay, iris sorted. So first of all, we are going to do so here for q1 our data point is from let's see iris 0 to 25, from 0 to 25, and we are going to calculate its middle value, because basically we are looking at this area only, and we are going to calculate middle value from here. So what is going to be the middle of from 0 to 25? It is going to be 12. uh, because we are not including, this is excluding 25 position, because we are doing everything simple here, not too complex. So 12. If we had taken 25th position, then we had to do something like 12 position 12 plus position 12 13 value divided by 2. We are not going to do right now that. So 12th position value is our q1. So q1 equals to iris sorted and 12. q1 q1 is our 1.4. Similarly, we can calculate q3 as well. Now let's see how we are going to calculate percentile. So uh, let's say we are going to calculate 90 percentile of petal length. Okay, so 90th percentile is for calculating percentile we are going to divide our data set into 100 group first of all, but we don't have to divide it, we are going to calculate mathematically right now. So uh, our length of our data set is 50, so we are going to take equivalent of 90th position in our 50. So let's say if we had a perfect 100 data points, then obviously for 90th percentile we should take 90th position, but our data points are only 50. So what should we take? Obviously divided by 2, 45. 45th position is our 90th percentile for our petal length. So we are going to calculate the iris petal length from 45 position is going to be our 19th percentile. Similarly, we can calculate other as well. So let's say for 10th percentile, what it would be? So let's say 100. So let's in ideal condition 100. If we had 100 data points, 10th percentile will be 10, but we have 50. 10 percentile is going to be 5. So our iris sorted 5. This is our 10th percentile. This 10 percentile is 1.3, and our 90th percentile is, oh no, not 90, 45. It will be out of index then. Okay, so let's see how we can do it using numpy native built-in functions. So numpy has something called np.percentile, and we are going to give that data. What is the data? It will going to we do not have to sort or anything like that. NumPy will handle all of things. So I am going to give iris setosa, simple iris setosa petal length only, and let's check our 90th percentile. It is 1.7. That is correct. Let's check our 10th percentile, 1.3. That is also correct. And let's check our Q2. What is going to be Q2 in our percentile? Obviously 50%, and this is 1.5, and this is also correct. And for Q1, let's calculate it as well. It will going to be 25 and 1.4. Q1 is 1.4. So we see that how we can calculate quartiles and deciles and percentiles. We don't we can calculate all of those things using percentiles, because percentiles is basically dividing everything in 100 groups, and we can take uh, just like say 25, 50 and 75 points to get quartiles. Also to get deciles we can take 10, 20, 30, 40 point to get deciles, and percentiles is basically dividing that data set in 100 groups and and taking each data point. So in this way you can calculate quantiles in NumPy, and we understood what is concept is all about. So basically, so what is the significance of these values, quantiles values? They will only signify that, let's say, since our data set is going to be in sorted order, increasing order, it will say that below 90% we have less than 1.7 value. It gives us that information. Below 10% we have one less than 1.3 petal length size. Below 50% we have less than 1.5 petal length. In this way we can calculate it. Thanks.